The melting point is one of the most important physical properties that is measured in the organic chemistry lab, and its measurement has important applications in the lab. The melting point, by definition, is the temperature at which the solid and the liquid phases of a pure substance coexist at 1 atmosphere. If you have a solid compound, and upon heating, this solid compound will start to melt or move from the solid state to the liquid state. Once the both states occur at the same time, this is called melting, and then the temperature at this point is called the melting point. What are the factors that affect the melting point of a solid? The first and the most important one is the strength of the intermolecular forces. As the strength of the intermolecular forces increases, the melting point increases, and this is because high energy is needed to separate and free molecules. We know that the main difference between the solid and liquid and gas state is the distance between molecules. So to force a compound to move from the solid state into the liquid state and then to the gas state, we have to increase this distance, and we have to separate the molecules from each other. If those molecules are strongly held by strong intermolecular forces, then high amount of energy is needed to separate them, and that's why the melting point in this case will be high. The second factor is the crystal structure. Some compounds have a crystal lattice structure, which is a highly organized form or arrangement of molecules. Those molecules which have a crystal lattice structure usually have higher melting points than those which don't have this crystal lattice structure, and usually they are called amorphous solids. Also, in this case, high energy is needed to break this highly organized structure, and this affects the melting point and increases it. The third factor is the pressure, the external pressure or the atmospheric pressure. Increasing the atmospheric pressure will increase the melting point also, because the pressure, the external pressure, will force the solid molecules to stay together, and separating them requires, in this case, more and more energy. Last factor which affects the melting point is the presence or the existence of impurities. Impurities are known to reduce the melting point of a compound. So usually, whenever the melting point of a compound deviates from its known literature value, this indicates that this compound or this solid is actually impure, because the impurities are reducing the melting point. Why do the impurities reduce the melting point? Because usually those impurities will disrupt the highly organized structure of the solid, and this reduces the strength of the intermolecular forces. So if you have a solid, a pure solid, its molecules will be organized in a certain way, such as in this way, and that's why breaking these the forces which hold these molecules together and separating them requires too much energy. However, the presence of an impurity in between will weaken this intermolecular forces, and that's why now it's easier to separate the molecules, and this leads to lower melting points. Also, the presence of impurities will affect the range of the melting point, as we will see in the next slide. So why do we use or measure melting points in the lab? First of all, sometimes we use it to identify compounds. Since melting points are of pure substances are well defined and known, and they have a very narrow range, if you are given an unknown compound and you are asked to identify this compound, by measuring its melting point and then comparing it to the literature values, you can identify the identity of this compound. Also, we use the melting point for checking the purity of a certain solid sample. In this case, the presence of impurities will reduce the melting point, and it will also increase the range of melting. So as you can see in the table here, compound A has a narrow range for the melting point, whereas compound B has a wide range for the melting point, and this is because of the presence of impurities. And as I said before, impurities will reduce the strength of the intermolecular forces, and this lowers the melting point. Also, because the impurity itself is going to melt at some point, that's why while observing or measuring the melting point, some of the molecules will melt at a low temperature. However, the other ones will melt at higher temperature because some of them are affected by the impurity, some of them are not, and also we have the impurity itself which is melting. So this causes a wide range change in the melting point, measured melting point. How do you measure a melting point in the lab? Usually the powder, which is a solid, is placed inside a capillary tube. The capillary tube is attached to a thermometer, and then the thermometer and the capillary tube are immersed in oil and heated. And the solid inside the capillary tube is observed. Upon heating, and once the solid starts to change into the liquid state, so a few droplets will appear inside the capillary tube. This indicates that melting started to take place and the temperature is recorded, and then we keep recording the temperature until all the solid melts, and this is basically how we get the range of the melting point. If your compound is pure, then this range will be very small, whereas if your compound is impure and it has lots of impurities, then the range will be high. There is also another apparatus which can be used to measure the melting point instead of using the thermometer and the oil bath, and it's called the melt temp, and this also helps in measuring the melting point in a more accurate way.